This is Mr. Gillum, and today we're going to learn a little bit about equivalent fractions. And hopefully by the end of this video, you'll be able to create your own equivalent fractions. Let's start by talking about what a fraction is, because I believe that sometimes we just forget what we're talking about and what a fraction represents. It is actually a representation in number form of the parts of a whole. And so, for example, I could have a whole, much like this, and exactly half of it shaded in. We use the word half, but half is actually represented. We have one of the two pieces shaded in. That's an example. This is a fraction. So this is the fraction part. Okay. We could have even a circle looking one too. We could have maybe 4 pieces and one of them shaded in. And so to represent that we have one of the 4 pieces shaded in, we would use the fraction 1/4. One part is shaded, one part, and altogether, to make a whole, there are 4 pieces. Okay, so the parts of a whole. So one part of the 2 pieces to make it whole. Okay, parts of a whole. That's what a fraction is. There are 2 parts of the fraction, the part on the top and the bottom. And there's a number for each one. So the numerator is the number on top of the fraction. So the numerator would be the 1 in the 1/2, or the 3 in the 3/4. So the numerator would be the top number, the 1 or the 3. The denominator of 1/2 or 3/4 would be the number on the bottom, the 2 or the 4. So I'm going to use the words numerator and denominator throughout this video. So it's going to be important to pay attention to when I say numerator. I'm talking about the top of the fraction. When I say denominator, I'll be talking about referring to the bottom of the fraction. Okay, so the numerator is the parts, the denominator is the whole. So here we go. Let's move on here. Equivalent fractions. Okay, so what I have up here is I have a diagram with 3 circles on it, okay? And the circles were all copied and pasted exactly the same size, all right? And they actually look like ovals now that I've enlarged this, but they are supposed to be circles. So pretend they're perfect circles, and we actually are going to come up with some fractions that represent the same parts of a whole. So the first circle here, I'm just going to divide it into 2 pieces, right through the middle, as best I can. So we're going to assume that both parts are equal. Okay, I'm going to divide this one into 4 parts, the best that I can. And I'm going to divide this one into 8 parts, the best that I can. And we're going to assume that that's perfectly divided, so each part is actually the same amount of space in each diagram. Now, what I'm going to do is I'm going to start to shade. Okay, I'm going to shade in the parts that I'm talking about. And so I'm going to shade in 1/2 of that, or one of the 2 pieces, and we call that 1/2. Okay, there's 1 part shaded for 2 parts that make it whole. And then on the next diagram, I'm going to, again, because these circles are the exact same size, I'm going to actually shade in the same amount that I did here of the circle. I'm going to shade in that same amount here, except for this time you can see that my parts of a whole are a little different. This time my parts of a whole are 2 parts out of the 4 whole pieces. Okay, or the 4 pieces that makes it whole, so 2/4. And again, I'm going to think the same thing here. I'm going to shade in the exact same amount of the circle, except for now my fraction is going to be just a little different. My parts of a whole, I now have 1, 2, 3, 4 parts out of the 8 total that make it whole. And so what I've actually done here is I'm representing the same amount of the same circle. This much amount of the circle, it's the same size circle, it's the same amount I'm representing, but I'm representing it 3 different ways, as 1/2, 2/4, or 4/8. And so what these are is these are actually equivalent fractions. It actually refers to the same amount in each one of these. Okay, the parts of a whole. Although the parts and the wholes are different, it still represents the same amount of the circle that's shaded. And so these are what equivalent fractions are, and we can use the equal sign for equivalent. Okay, 1/2 is equal to 2/4 is equal to 4/8. The same amount, if I just copied this much and moved it straight over here, it would be the same amount here and the same amount here. So those fractions represent the same parts of a whole. Hopefully that's a good reminder of how equivalent fractions work. Before I move to the next slide, I do also want to point out that if you look at the relationship here, there is a multiplication relationship. If I multiply 1 by 2, I get 2, and if I multiply 2 by 2, I get 4. Same way here, if I multiply 2 by 2, I get 4, and if I multiply 4 by 2, I get 8. If I look from the first to the last, I can multiply the 1 by 4 and get 4, or the 2 by 4 and get 8. And so I see that there's a multiplication pattern here. I also see that if I wanted to go backwards from 2 to 1, I could divide by 2. I could also, from 4 to 2, divide by 2. And the same way here, I could change that 8 into a 4 by dividing by 2, and a 4 into 2 by dividing by 2. Or I could go from all the way over 4 to 1 by dividing by 4, or from 8 to 2 by dividing by 4 again. And what I notice in between any of these fractions that I'm moving forwards or backwards with multiplication or division, I'm multiplying or dividing by the same number on the top of the fraction that I am on the bottom of the fraction. Okay, and that's keeping them equivalent. If I multiply the top by the same number as the bottom, I'll have another fraction that's also equivalent. Okay, so let's take a little peek here. We're going to start practicing with some equivalent fractions, and I picked some specific ones that I want to go over. It says that we can find equivalent fractions by increasing through multiplication or decreasing through division. The numerator and the denominator by the same factor. Okay, so we're going to either multiply the numerator and denominator by the same number, or we're going to divide the numerator and the denominator by the same number. That's actually going to give us an equivalent fraction. And we saw that pattern in these first three fractions that we determined must be equivalent. So let's take a look here at the number 12/16. Now, I'm not a big fan of multiplying big numbers. And so I have two options here. I can either choose to multiply it by any number that I choose. As long as I multiply the top and bottom by the same number, I'll have an equivalent fraction. So let's start by multiplying by 2 on the top and the bottom. Now, a lot of times, 5th graders, just becoming 6th graders, are not familiar with this little point that I made here. It looks like a decimal point. That's actually a shortcut for a multiplication sign. Okay, we're going to start using this point as our multiplication sign because very soon this will become a variable, and we'll learn more about that later. Okay, so we're going to start using points, or little circles, or little those guys, and therefore multiplication from now on. So I'm going to multiply by 2 on the top and on the bottom, and what I actually wrote it as is a fraction, 2/2. And I'm going to explain that a little more in just a second, but I know that 12 times 2 is 24, and 16 times 2 is 32, so I know that one equivalent fraction, this is my first one, would be 24/32. That's the same parts of a whole as 12/16. Okay, I want to point out here that I multiplied by 2/2. I multiplied the top by 2 and the bottom by 2, but I wrote it as 2/2. And the reason I did that was because I want us to start knowing or learning that the reason that these are equivalent fractions is because the fraction 2/2 is equivalent to 1. It's equal to 1, and when I multiply any number by 1, it doesn't change. Okay, it still represents the same amount. So there's one. I could go from there. I could choose, let's do, it says to write 3 equivalent fractions. Okay, 12/16. I did one with multiplication. Let's do one with division. If I divide the top by 2 and the bottom by 2, and now I chose 2 because I see that they're both even numbers. I know that 2 will go into both of them evenly. Then I know I would have 6/8. That would be an equivalent fraction. There's our second one. Okay, and I could move from 12/16. I could even do 4. If I wanted to, 12/16, I could divide by, I know that 4 goes into 12 and 16. I could divide them both by 4, and I could see that I have 3/4. That would be an equivalent fraction. Or I could continue to do multiplication. I could do 12/16 times, let's choose 3 this time. And when I multiply the top and the bottom by 3, I get 36/48, another equivalent fraction. So there's the third one. I even did a bonus one, the fourth one. Okay, so as long as I'm multiplying or dividing the top and bottom by the same number, I will have an equivalent fraction. Let's do one more example here. 15/25. The first thing I notice is that 15 and 25 both share a factor of 5. And so what I'm going to do is I'm going to start with division. I'm going to divide by 5 on the top and the bottom. And I know that my first equivalent fraction could be 3/5. There's one. 15/25. Let's see here. What else could I do? I could multiply. And I like to multiply by smaller numbers. I could multiply both the top and bottom by 10. That would be a good number to multiply by. Those are easy to calculate. But I chose 2 this time. So if I multiply by 2 on the top, I have 30. And on the bottom, I have 50. That would be an equivalent fraction. There's the second one. And again, another equivalent fraction, like I kind of mentioned it here. 15/25. If I would like another equivalent fraction, I could multiply by 10 on the top and bottom. That would be one that's easy to calculate. 150 over 250. That would be equivalent. There's a third one. And so, depending on the numbers you can multiply or divide, choose a number that makes sense. For instance, I didn't try to divide 12/16 by 5 on the top and bottom because 5 doesn't go evenly into 12 or 16, so that wouldn't be a good choice to do. Okay, I want to choose numbers that will divide evenly into these. So I believe there's 2 more examples on your paper there. I'm going to save those for class, and that's all I need you to have done for your notes for today.